The compound interest formula. Use the formula for maturity value to find the compound amount given the criteria below. Round to the nearest cent. The formula for maturity value using compounded interest is M equals P times 1 plus I to the n power. This means that we need to find the value for I and n first before we can use the maturity value formula. I is the interest rate per compounding period. And we find that value by taking the interest rate per year and dividing it by the number of compounding periods in a year. So the interest rate per year is 5%, which is 0.05. And we'll divide that by the number of compounding periods in a year. Our problem tells us that the account is compounded semi-annually. Semi means 2, so that's 2 times a year. So we're going to divide by 2. 0.05 divided by 2 gives us a value of 0.025. And that is our value for I. Next, we want to find the value for n. N is the total number of compounding periods. That's found by taking the number of compounding periods in a year and multiplying it by the number of years. So the number of compounding periods in 1 year is again semi-annually, so that's 2. And then the number of years is 4. 2 times 4 is 8. So n equals 8. Now that I know my values for P, R, I, and N, I can substitute them into the formula and solve for the maturity value. So M equals the principal, which is $3,600, times 1 plus I, which is 0.025, and that's all being raised to the 8th power. The first step in solving this formula is to perform the calculation within parentheses. So 1 plus 0.025 is 1.025. The next step is to apply the exponent. So we're going to raise 1.025 to the 8th power. And we should do this on our calculator. When you do that, we get a very long decimal of 1.218402898. And lastly, we're going to multiply that decimal to 3,600. And we get an answer of 4,386.250431. And the maturity value is a monetary value, so we need to round to the nearest cent or 2 decimal places. So if we look at the number next to the 5, that's a 0, since 0 is less than 5. I keep the 5 as is, and my final answer is $4,386.25. Find the compound interest of an account if a principal of $15,000 was invested at a rate of 3% and was compounded quarterly for 8 years. Round to the nearest cent. The compound interest, or the amount of compound interest, is given by the formula I equals M minus P. So we need to find M, the maturity value, first in order to find our final answer. Recall that M equals P times 1 plus I to the nth power. So we need to identify the values for I and N before we can find M. The values for P and R are already given. So P was 15,000 and R was 3%, which is 0.03. I is the interest rate per compounding period. So To find I, we'll just take the interest rate, which is 0.03, and divide it by the number of compounding periods. This problem tells us that the account is compounded quarterly. Quarterly means 4 times a year, so we'll divide by 4. 0.03 divided by 4 gives us a decimal of 0.0075. So that is our value for I. Next, we'll find the value for N. N is the total number of compounding periods, and that's found by taking the number of compounding periods in a year and multiplying it by the number of years. So again, this is compounded quarterly, or 4 times a year, so we'll multiply 4 by the number of years, which is 8. 4 times 8 is 32, so N equals 32. Next, we'll take the values for P, R, I, and N and plug them into the formula for maturity value. So we have a formula of M equals 15,000 times 1 plus 0.0075 raised to the 32nd power. And we're going to solve for M. First, you'll do the operation within the parentheses. 1 plus 0.0075 is 1.0075. Next, we'll use the exponent operation and raise 1.0075 to the 32nd power. When you do that, you should get 1.270111224. Lastly, we'll multiply that decimal to 15,000, and we'll get an answer of 19,051.66836. This is a monetary value, so we need to round to 2 decimal places, and our final answer for M is $19,051.67. Now we'll take that number and plug it into our formula for the amount of compound interest to solve for I. I equals $19,051.67 minus $15,000. When you subtract these two values, you get $4,051.67. And that is the final answer to this problem. Marcy deposits $1,200 into her savings account, earning 2% interest. If the account is compounded monthly for 10 years, what is the compound amount? Round to the nearest cent. So compound amount is the same as maturity value, or the future value. It's how much total of the principal and the interest that we'll earn using compound interest. The formula is M equals P times 1 plus I to the nth power. First, we need to identify I and N. So I is the interest rate per compounding period, and that is found by taking the interest rate, which is 0.02, and dividing by the number of compounding periods a year. And this account is compounded monthly, so that's 12 times a year. And 0.02 divided by 12 gives us a decimal of 0.00166666, repeating. N is the total number of compounding periods, and that's found by multiplying the number of compounding periods in a year by the number of years. So again, this account is compounded monthly, so that's 12 times a year. And it's going to be compounded for 10 years total. So 12 times 10 is 120. That means N equals 120. Next, we'll substitute those values into the formula to solve for M. P is 1,200, and then I was that 0.00166666, repeating, and N is 120. First, you'll add the numbers in parentheses. Next, you'll raise that value to the 120th power. And you should get a decimal of 1.221199434. And lastly, we're going to multiply that value by 1,200 to get 1,465.43931. And this is a monetary value, so we want to round to the nearest cent or 2 decimal places. We'll look at the 3, and the number next to the 3 is a 9. 9 is greater than 5, so we'll round that 3 up to a 4. And our final answer is $1,465.44. And that is our compound amount or maturity value.